It's been a pleasure working with the ESA team throughout this campaign, and we wish you all the best in commissioning your spacecraft.
All right, T-minus 2 minutes and 48 seconds. We are just moments away. Standing by now for auto sequence start at T-minus 2 minutes. Here we go. Let's listen into that countdown now.
To all operators, we are go for auto sequence start at T-minus 2 minutes. LDs go for launch.
The vehicle is fully on internal power. AFTS is green and enabled for flight.
Alongside complete, the system is in recirculation. Anti-geyser ring is disabled.
Stage 1 and Stage 2 tanks are pressed. High flow engine purge enabled.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Stage 1 propulsion nominal.
A beautiful nighttime launch of Electron from LC1, and there goes the daughter of the stars on her way to orbit for the LEO PNT constellation and ESA for the very first time. Now Electron's flight computer will soon command the engines to throttle back in preparation to pass through max Q, or maximum aerodynamic pressure, that moment in flight when the pressures against the rocket are at their peak as it climbs through the atmosphere.
Approaching max Q. Cleared max Q.
And there it is, that's max Q cleared by Electron as it continues to orbit. The 9 Rutherford engines at the bottom of Electron's first stage are keeping that mission on track, now at more than 2,500 kilometres an hour, well above 20 kilometres in altitude.
In about a minute's time, we're expecting to see those engines power down completely to allow for a quick series of events across the vehicle's first and second stages. Engine shutdown is called MECO, or main engine cutoff, and it happens just a couple of seconds before the second stage is released along its flight path to allow for a clean separation of the stages.
Then the single Rutherford engine on the second stage ignites to continue along that trajectory and build up enough velocity to achieve orbit. 3 events coming up in quick succession, so let's check back in with the operators for confirmation.
"15 seconds to staging. Entered burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
Nicely done by Electron. As you've just heard, that was MECO, stage separation, and second stage ignition for Daughter of the Stars. Electron's speed and altitude are looking nominal as we approach fairing separation, when the nose cone covering the IOD 1 and 2 spacecraft will split in half and leave the vehicle.
Fairing jettison confirmed.
A nominal separation of the fairing for Electron, and for the first time, ESA's 2 satellites for its Celeste mission are exposed to space. All up, the flight time for the second stage is about 6.5 minutes to achieve orbital insertion. Now, we've got a couple of minutes between now and our next milestone event for the second stage, called the battery hot swap, scheduled to take place at around T plus 6 minutes and 32 seconds. Otherwise, everything is looking nominal across Electron's performance, which you can track by our speed and altitude dials in the top right-hand side of your screen.
Stage 2 propulsion holding nominal.
All right, a minute to go before our next milestone event for the second stage, the battery hot swap. Now, our propulsion system uses batteries to feed propellant into the Rutherford engines. And since the second stage engine burn lasts longer than the first, it starts with several battery packs to power its electric pumps. But as that engine burn continues after the first packs are drained, carrying dead batteries is inefficient.
Yeah, so Stage 2 propulsion system instead switches to the newer battery packs for its power source and gets rid of the old ones without interrupting the engine. That is why we call it the battery hot swap, and you can sometimes see the old battery packs on your screen as they're dropped from the vehicle. So keep an eye out for that moment around T plus 6 minutes and 32 seconds while we listen in to mission control at the same time.
Guidance is nominal, 200 seconds remaining.
HVP discharge holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down. Battery jettison confirmed.
Beautifully done there with both the visual and comms confirmation that battery hot swap was successful for Electron's second stage engine. This fresh pack will power the vehicle for another 2.5 minutes while we continue to increase our velocity. Then the second stage will separate from the kick stage that's carrying the ESA satellites, sending it on its way to reach orbit and completing the first phase of the mission for Daughter of the Stars.
HVB discharge holding nominal.
The second stage operations are complete. Electron's kick stage is released into a nominal transfer orbit, which is exactly where we expect to be. Now, this transfer orbit is typically elliptical, which means that our lowest point and highest point are actually different. So, to reach the mission's desired final circular orbit, the kick stage actually needs to maneuver ESA's satellites into position. But first, we need to reach that nominal transfer orbit following separation from the second stage, which is coming up in about a minute.
Yes, what we'll see there is Electron complete the same actions for the second stage as it did with the first. Instead of MECO, though, we'll have SECO on the second stage. The Rutherford engine will shut down before separation of the kick stage from the second stage puts it into that nominal transfer orbit we just talked about. It's another quick sequence of events, just 4 seconds or so in total, and it's scheduled to take place at T+9 minutes, so let's listen in.
Entered burnout detect mode. Guidance is in terminal, 20 seconds remaining.
SECO confirmed.
Stage separation confirmed. Nominal transfer orbit achieved.
Excellent work there by Electron. That's SECO and kick stage separation confirmed, with ESA's satellites off and on their way soon to begin their mission. Just under 10 minutes work on your screens there, but months of work by the ESA and Rocket Lab teams coming together for this monumental launch.
Now, before we reach payload deployment on this mission, the kick stage's journey around Earth takes about 40 minutes or so before it's in the right place to deploy ESA's satellites. During this time, we're out of ground station coverage for the most part, so we're going to take a break in the broadcast for now, but we'll be back to see out the final moments of the launch before the Celeste mission begins for ESA with payload deployment. Join us again soon.
Hello and welcome back to the broadcast for Daughter of the Stars, our Electron launch for the Celeste mission by the European Space Agency to test navigation technologies in LEO for a future European constellation. We had a successful liftoff today at 22:14 local time from LC1 in New Zealand, completing all the usual launch milestones by Electron to reach the last phase of the mission, deploying the satellites to their final orbit.
Well, while we were off air, Electron's kick stage, with ESA's satellites on board, completed its nominal transfer orbit, travelling around Earth before lighting its engine to reposition into a circular orbit at 510 kilometres in altitude. We are listening out now for the end of that Curie engine burn from our operators in mission control, which will then mean we're only a matter of seconds away from the first of 2 payload deployments for this mission. Let's listen in now for Curie engine shutdown confirmation.
Carry cutoff confirmed.
Nominal final orbit achieved.
There we go. Engine shutdown achieved on the kick stage. Now less than a minute until payload deployment for the first of ESA's satellites, the IOD-1 spacecraft by GMV. Let's follow along.
Payload 1 separation confirmed.
Payload deployment confirmed there for the first of ESA's Celeste satellites, IOD-1. Congratulations to ESA and the industrial team as your mission in low Earth orbit begins.
Next up will be payload deployment for the second and final satellite on board. That deployment is scheduled to take place at around T plus 54 minutes and 6 seconds on the mission clock, so we've got about 3 minutes to go, but a lot can happen in those 3 minutes.
That's right. At the speeds we're going, we'll be travelling approximately 1,500 kilometres over the ground from west of Morocco all the way north off the coast of Ireland. Along the way, our reaction control system will initiate a very specific manoeuvre to orient us in the required direction for payload deployment. The RCS thrusters on our Curie engine are responsible for our pinpoint accuracy and also allow us to do altitude raising and lowering manoeuvres as well as plane changes.
That's right, and we've sent more than 80 Curie engine modules to space, including the Hyper Curie variant used in our Capstone mission to the moon for NASA. Along with the Rutherford engines on stage 1 and 2, that's over 900 of our 3D printed engines sent to space. And today's 2 spacecraft will take us over 250 satellites deployed to orbit, plus 1 to lunar orbit, all by our workhorse small-sat launcher Electron.
That's right, and Rocket Lab didn't just launch that satellite to the moon, we built it as well. Our Space Systems team are hard at work on several programs, and late last year, our 2 Mars-orbiting satellites were deployed into space to begin their journey to the Red Planet. They're currently at a parking spot in space at a Lagrange point, awaiting a planetary alignment until they can continue their journey to Mars to measure the planet's magnetosphere. They're currently holding course at L2, which is the same Lagrange point that's home to the James Webb Space Telescope, about 1.5 million kilometres away from Earth. Now, once Earth and Mars align in the 4th quarter of 2026, the twin spacecraft will then use Earth's gravity to slingshot towards Mars.
Okay, let's bring things back down to Earth, or at least a little closer. We're about a minute away from payload deployment for the final ESA satellite from Electron's kick stage. As we mentioned earlier, we'll be firing up the RCS to point us in the desired direction for deployment, and then it won't be long until IOD-2 is released from its deployer. Here's that animation again to see how the second deployment differs from the first while we listen into mission control in real time and getting that confirmation live.
Payload 2 separation confirmed.
Payload deployment confirmed for IOD-2 and confirming full mission success once again by Electron, this time for the European Space Agency. Welcome to space and the beginning of a new chapter in satellite navigation for Europe. The Daughter of the Stars has joined Galileo in space. Congratulations to the ESA and Rocket Lab teams, our first mission for the European Space Agency and our 85th launch overall for our Electron rocket.
And also a big congratulations to the team at LC1, demonstrating the value, of course, of multiple pads at launch sites around the world. A smooth turn from Pad B back to Pad A, rollout, wet dress, all within a few days. We'll have another mission ready on the launch pad before you know it, so keep an eye on our website and social media channels for updates about our next mission. Thank you so much for joining us. This is Rocket Lab Mission Control, signing off.